Welcome to the problem solving session for the week 4 on the topic Streamflow Measurement for the NPTEL course Surface Water Hydrology being taken by Professor Dr. Rajiv Maiti from the Department of Civil Engineering IIT Kharagpur. I am the teaching assistant Aman Shrivastava, and today we will be solving some problems on streamflow measurement such that the enrolled candidates can be able to solve the weekly assignment on the NPTEL portal. So today in this problem solving session, we will be focusing on three aspects of streamflow measurement, that is calculation of discharge, moving board method, and slope area method. So let's start with calculation of discharge. Here is the first problem. Let me read the problem for you. A sharp-crested weir with vertical sides as a height of 1 meter and width of 6 meter is provided. The head above the weir is 0.8 meter. Evaluate the discharge in meter cube per second, assuming the values of CD equal to 0.48. Okay, so here the sharp crested weir is provided and the dimension is also given, that is height 1 meter and width 6 meter. The head is also provided, which is 0.8 meter, and CD value is also given, coefficient of discharge, that is 0.48, and we need to estimate the discharge in meter cube per second. So let's solve this problem. In the step 1, we need to find out the discharge, which is the ultimate goal of this problem. So there will be only one step. So this is what is the equation you need to remember for estimating the discharge, which is 2 by 3 into CD into B. B is the width, and into under root 2G. G is the acceleration due to gravity, and H is the head, which is provided, power 3 by 2. Substituting all these values from the problem, that is 2 by 3 into 0.48 into 6 into 2 into 9.81 into 0.8 power 3 by 2. Okay, you will get the discharge value is 6.08 meter cube per second. This is the final response for such problem. So this was the very easy problem where mere substitution of the values provided in the problem in the equation provided us the final response. Let's move ahead and solve the another problem on a moving board method. That is the problem 2 of the today's session. Let me read the problem for you. Moving board method is used to measure the discharge at a site. For a particular segment, it is observed that the magnitude of surface velocity is 6 meter per second and the direction of velocity is 75 degree. The width and the depth of that segment are 9 meter and 5 meter respectively. Evaluate the segmental discharge assuming the mean velocity for a segment to be 0.75 times the surface velocity measured by the instrument. So they have clearly indicated to utilize moving board method, and for which they have provided the surface velocity is 6 meter per second. They've also provided the dimension of the segment to be considered, which is 9 meter and 5 meter respectively, that is the width and depth. And we are required to find out the segmental discharge for this segment such that here the mean velocity is 0.75 times the surface velocity, which is 6 meter per second, which is provided. Okay, so utilizing this data, let's see how to solve this problem. In the step 1, we need to find out the average velocity for the segment if the surface velocity is 6 meter per second. Okay, so let's see how to find out this. So V average or the mean velocity is equal to 0.75 times, that is provided in the problem, into VR sine theta. Okay, and here this VR is given, that is 6 meter per second, and theta value, that is the direction, is also given, that is 75 degrees. So substituting these values in this equation, we get average velocity as 4.35 meter per second. I hope you were able to follow this discussion. In the step 2, let's find out the discharge for the segment. Okay, so here first of all we need to utilize the continuity equation to find out the discharge, that is A into V average. Okay, so mean velocity value we just obtained, and area, how to obtain area? The segmental dimensions was provided, that is width and depth, which was 9 meter and 5 meter respectively. So the area came as 45 meter square. Substituting this value in the discharge equation or the continuity equation, we get 45 into 4.35 as 195.6 meter cube per second. So this is the final response, that is the discharge value as 195.6 meter cube per second. Okay, I hope you were able to follow the moving board method. Let's switch to the third and the last problem for the today's live interactive session, that is slope area method. Let me read the problem. The flow depths in a 10 meter wide rectangular channel at two sections 20 meter apart are 6 meters, that is section A, and 4 meter, that is section B. The flow velocity at section A is 5 meter per second and eddy loss between these two sections may be assumed to be 0 and gravitational acceleration G as 9.81 meter square per second. Okay, this should be 9.81 meter per second square. Okay, apologies for this mistake. Evaluate the drop in water surface elevation and the energy slope between these two sections. Okay, so here we are required to find out two aspects, that is drop in water surface elevation and energy slope, for which the depth is provided, that is 6 meter and 4 meter at section A and section B, and the other dimensions included the diameter width of the rectangular channel, and these two sections, that is section A and section B, are 20 meter apart. Also the velocity at section A 5 meter per second is given to us, and let's see how we can utilize this information to obtain drop in water surface elevation and the energy slope between these two sections. In this step 1, let's first of all find out the area at section A and section B. Okay, so it is very apparent that at section A the area symbol will be AA and for B it will be AB, and the width and depth will be B and H respectively. These are the symbols that we will be utilizing. So area at section A, that is AA, will be B into HA, and the width B is given, that is 10 meter, and the HA, the initial depth was 6 meter. So we get the area 60 meter square. Likewise, area at section B was 10 into 4, that is 40 meter square. Okay, so this is how we have done with step 1. Now in the step 2, let's find out the velocity at section B. As you remember, in the problem, the velocity at section A was only given and not at section B. So let's use the continuity equation to obtain the velocity at section B. So AA VA is equal to AB VB. Okay, here only thing which is unknown is VB. So let's rearrange this equation, and now we are having VB is equal to AA VA divided by AB. Now all these three aspects are known. So substituting, we get VB as 7.5 meter per second. Okay, so this is how we have obtained the velocity at section B as well. Now move to step 3, where we need to find out the first aspect of the problem, that is a drop in the water surface elevation. Let's see how to find out this. So there is one equation for the same, that is drop in water surface elevation HL, which is equal to HF plus HE. Okay, so here HE is equal to 0 as there is no eddy loss. So only thing over which the drop in water surface elevation will depend is HF. Okay, and here this HF can be expressed as HA minus HB plus VA square upon 2G minus VB square upon 2G. Okay, for more information on this, please refer to the weekly slides being taken by Professor Dr. Rajiv Maiti in the regular lecture hours. Okay, so this is how we can express HF as HA minus HB plus VA square upon 2G minus VB square upon 2G. And all these values are known. So let's substitute all these values here. So HA and HB was known, 6 minus 4, and VA was already provided in the problem, which was 5 meter per second, and VB just now we obtained in the step 2, which was 7.5 meter per second. Substituting all these values, we obtain the drop in water surface elevation HL as 0.407 meter. So this is how we have obtained the response to the first aspect of this problem. Moving ahead, now let's try to find out the energy slope, and this is the equation for the energy slope, that is HF upon L. So in the previous step itself we identified HF. Okay, so HF value was 0.407, and now the length between these 2 points, that is section A and section B, this is what the energy slope that we need to find out between the two sections. So that length was 20 meter, which was already provided in the problem. So 0.407 divided by 20 yield 0.02, which is the energy slope. So I hope you were able to follow all these 3 questions that were very straightforward questions. Today in this lecture we primarily focused on 3 aspects of streamflow measurement, that is calculation of discharge, moving board method, and slope area method. Please stay tuned for more lectures on the problem solving sessions for the remaining weeks of the NPTEL course Surface Water Hydrology, and we will be solving more problems in the coming weeks to come. Okay, so kindly stay connected. Thank you.